Silence. It's 11 p.m. The only source of light in the dark apartment is the cold blue glow of an open refrigerator door. You stand in front of it, staring at a plate of leftovers or a slice of sweet pie. Your hand reaches out on autopilot. Sounds familiar? At this moment, you feel a slight pang of guilt and think, again, where is my willpower? We are used to seeing this as a personal failure. Society has been telling us for decades, if you overeat at night, you're just lazy, you lack discipline, you have no backbone. Pull yourself together, just don't open your mouth after 6 p.m. It seems perfectly clear. There are bad habits and there is good discipline. A battle between good and evil on the stage of a chessboard kitchen. This old consensus worked for everyone, from fitness trainers to self-help gurus. But what if this picture is completely wrong? What if, at this very second, you are not the one making the decision? What if a mechanism is driving your hand?
This chemical mechanism was hardwired into our DNA long before the dawn of civilization. Let's travel back to the year 1998. Social psychologist Roy Baumeister decided to test how our praised willpower actually works. He conducted a simple yet elegant experiment. Hungry students were invited to a lab filled with the scent of fresh chocolate cookies. On the table stood 2 bowls, one with cookies, one with raw radishes. The researchers split the participants into groups. The first group was allowed to eat cookies. The second group got unlucky. They were ordered to eat only radishes. Imagine their state. The students sat in front of a plate of warm, aromatic pastries, forcing themselves to chew on bitter radishes. At that moment, their prefrontal cortex, the brain area responsible for self-control, was working at its limit, literally burning resources. Then came the second part of the experiment. Both groups were given a complex geometric puzzle that actually had no solution. The scientists simply timed how many minutes a hungry, exhausted person would struggle before giving up and quitting the useless task. The results were mind-blowing. Those who had eaten cookies and spent no energy on self-control kept trying to solve the puzzle for an average of 19 minutes. But the group that had to restrain themselves in front of the bowl of radishes gave up after just 8 minutes. They were completely mentally drained. This experiment turned our understanding of the human psyche upside down, introducing the revolutionary concept of ego depletion. Willpower is not an abstract moral virtue. It is a finite, highly expensive cognitive resource for our body. Every decision made during the day, every effort to stay quiet when your boss is being harsh, drains the precious battery of your prefrontal cortex. Every choice between an important report and social media relentlessly drains this resource. By 11 p.m., the battery hits absolute zero. This brings on what scientists call decision fatigue. The prefrontal cortex shuts down, handing the remote control over to ancient structures. These ancient limbic structures don't know how to think about the distant future. Their main task is to help you survive right here and now. But if it's just about brain fatigue, why don't we crave a healthy salad after a hard day? Why does the brain demand a calorie bomb? The answer lies in a hormonal conspiracy unfolding in your body every single second of an ordinary, stressful workday. Whenever you face trouble, whether it's a missed deadline, a colleague's sharp tone, or endless traffic on your way home, your body sees absolutely no difference between a bad annual report and an attack by a dangerous, saber-toothed cat. For your biology, any high stress is a direct threat to survival. At that moment, a complex chain reaction starts in your body. The hypothalamic pituitary adrenal axis is activated. It sounds complicated, but it's really just your internal alarm system. The end product of this fine-tuned system is cortisol, the primary and most active stress hormone in our body. In our evolutionary past, a high level of cortisol meant only one thing: hard and dangerous physical work lay ahead. An ancient human had to either fight an enemy or run. To survive, their muscles desperately needed fast-burning fuel. Obeying an ancient survival protocol, cortisol immediately commands the liver to dump its glucose reserves into the bloodstream. The body mobilizes all its forces. But here lies the tragedy of modern humans. We no longer run in fear from wild tigers. We keep sitting motionless in an office chair or standing in a crowded subway car. No real physical release ever happens. The muscles never burn the glucose that cortisol so carefully and quickly released into the blood during your daytime stress. Once the mental storm quietens down, the body faces a paradox.
On one hand, no actual calories were burned. You just sat in front of a screen and got angry. On the other hand, the hormonal system registered a state of emergency. From your body's perspective, you just completed a brutal march to save your life, which means those resources must be replaced immediately. Cortisol begins to directly control your appetite. It doesn't just make you hungry, it makes your hunger highly selective. The brain instantly shuts down interest in complex carbs and proteins. Why would it want broccoli or boiled chicken breast? To break down healthy food and extract clean energy from it, our exhausted body would need way too much time. But the body senses that a deadly threat is still lurking nearby, and it needs high-octane fuel right this second. The body aggressively demands foods with maximum energy density, meaning those packed with lots of sugar and fat. For an exhausted brain, this is the easiest and fastest way to get a dose of readily available fast glucose. By evening, the worn-out prefrontal cortex can no longer fight this pressure. Control shifts entirely to the limbic system. You open the fridge not because your stomach is hungry. You open it because your brain is terrified and completely exhausted. And this is where the food industry steps in. Corporations figured out this evolutionary bug long ago and learned to hack us down to the milligram. When an exhausted brain demands to replenish spent energy, it isn't just looking for calories, it is desperately looking for dopamine. Contrary to popular myth, dopamine is not a hormone of pleasure. It is the neurotransmitter of anticipation, promise, and motivation. It drives us to act by painting a picture of a sweet reward. When you eat something sweet or fatty after a tough day, your blood glucose level spikes.
The brain interprets this as an incredible survival victory in a harsh, unforgiving world. In response, a massive dopamine explosion occurs in the nucleus accumbens, the brain's primary pleasure center. Against the backdrop of a gray day filled with stress and anxiety, this chemical surge feels like a genuine lifesaver. Essentially, an exhausted person uses high-calorie food as the fastest, legal, and most accessible drug to alter their biochemistry. It is the easiest way to regain control over reality, soothe frayed nerves, and feel completely safe. And major food corporations know about this physiological vulnerability of ours all too well. They use it to their advantage. In the food industry, there is an iconic term, the bliss point. It was coined by American researcher Howard Moskowitz. This is not a poetic metaphor, but a highly calculated mathematical formula for the perfect ratio of sugar, fat, and salt in a product. This ratio triggers the maximum possible release of dopamine while cleverly bypassing the body's natural limits. Normally, a healthy person always has a protective mechanism called sensory-specific satiety of their taste receptors. If you were to eat only boiled meat or only bananas, very soon your brain would tire of that single flavor profile. A mild aversion would kick in and you would stop. But products designed around the bliss point break this safety valve. They are engineered so that the flavor remains incredibly appealing, but never overloads your taste receptors too much. The brain simply doesn't realize that it is already saturated with a specific nutrient and keeps demanding more. That is why you can mindlessly eat a giant bag of chips or a box of cookies while staring at your computer screen. And you only feel full when there is physically no room left inside for another single bite of food. What you are doing at the refrigerator at 11 p.m. is not satisfying physical hunger. You are playing someone else's game. You are looking for comfort. And food giants learned long ago how to package that comfort in bright, crunchy wrappers. For most people, this struggle is limited to occasional weekend slips. But for some, nightly kitchen raids become a rigid system. Breaking this system with willpower alone becomes impossible. At this moment, a common habit crosses an invisible line. Beyond this line lies a clinical diagnosis that requires a completely different approach and understanding of the processes. What we usually write off as simple lack of discipline has had a clear scientific description in medicine for a long time. In 1955, American psychiatrist Albert Stunkard of the University of Pennsylvania studied people with severe obesity. Stunkard noticed a strange pattern. Many patients barely touched food during the first half of the day.
But after sunset, their behavior changed drastically. They consumed an abnormally large amount of calories. The scientist first described this specific condition as night eating syndrome, opening a brand new chapter in dietetics. It's crucial to understand the difference. This is not binge eating, where a person consumes a mountain of food in 30 minutes. During a classic binge, a person destroys thousands of calories until their stomach hurts, feeling intense shame. Night eating syndrome is a quiet, continuous grazing that stretches over several evening hours. A person can drift from the couch to the fridge for hours, eating tiny bits. A cookie here, a slice of cheese there, a handful of nuts. In modern medicine, this syndrome has strict clinical criteria that doctors use to make a diagnosis. First, you consistently consume at least a quarter of your daily calories after your evening meal. Second, you have absolutely no appetite in the morning. Breakfast triggers a mild physiological aversion. A simple cup of strong coffee replaces a full meal. Third, you wake up in the middle of the night with an urge to eat. Without this night snack, you physically cannot fall back asleep and continue your night's rest. At the same time, you are fully aware of your actions while eating, which is fundamentally different from sleepwalking. And finally, your mood consistently worsens as evening approaches, giving way to rising anxiety and gloom. Why does this happen? The answer lies in a deep disruption of circadian rhythms and total hormonal chaos. People with this syndrome have broken internal biological clocks. The hunger hormone, ghrelin, remains abnormally high. Normally, ghrelin should drop at night, but due to chronic daytime stress and sleep deprivation, it keeps demanding food. Meanwhile, leptin, the satiety hormone that normally rises at night to protect our sleep from hunger, drops instead.
As a result, the tired brain physically receives no signal of fullness, even if the stomach is completely stuffed. Add to this a disrupted production of melatonin, the sleep hormone. Its peak release shifts to a much later hour. This robs a person of proper rest and leaves the brain's wakefulness centers in active food-seeking mode. Imagine this state: 3 a.m., complete darkness and silence. You lie in bed, unable to fall asleep. Your own brain is literally screaming that you will starve to death if you don't eat a slice of bread right now. This is not a whim. It's a physical illusion of energy deficit created by your body's broken hormonal clock. You walk to the kitchen in total solitude, feeling like a helpless hostage to your own body and hormones. But why did nature create such a cruel and destructive mechanism? Why did evolution preserve this bug in us? To solve this mystery, we have to take a short journey back in time, about 50,000 years ago. In 1962, prominent geneticist James Neal put forward a concept known as the thrifty gene hypothesis. Its core is simple yet fundamental. For millions of years, our ancestors lived under conditions of extreme calorie scarcity. Famine was not a temporary inconvenience, but a constant companion. Natural selection worked ruthlessly. Only those individuals whose bodies were highly efficient at turning any available food into fat reserves survived. Sweet fruits or fatty meat were extremely rare in the wild and were valued like gold. If an ancient human found a ripe fruit or wild honey, their brain instantly launched a harsh evolutionary algorithm. The algorithm demanded, Eat everything you can right now, completely ignoring any signals of fullness. Tomorrow, this resource will be gone, and a layer of fat will save your life during the next drought or freezing winter. And the best time for this was precisely in the evening, when daytime worries and dangers were left behind.
During the day, humans were in a state of constant physical tension, tracking prey or hiding from predators. Daytime stress required maximum resource concentration. Only in the evening, around the campfire, did the tension fade. It was the perfect moment to quietly replenish energy reserves and prepare the body for the next day. Today, we live in a world where food is available 24/7 and supermarkets offer an unlimited supply of calories. But our biological software hasn't been updated since the Paleolithic era. We are running old software on new hardware. When you spend a hard day at the office, solving complex tasks and suppressing emotions, your brain experiences immense stress. The prefrontal cortex uses up its entire resource. Cortisol gives a false signal of critical energy loss, and by evening, when you finally end up at home on the couch, in safety by the modern equivalent of the campfire, your ancient brain obediently boots up its genetic program. We survive today. We are safe. It is dark outside. We must immediately eat the most calorie-dense food to guarantee survival tomorrow and get through possible famine. We try to solve this deep biological problem using guilt and constant moral self-flagellation. We blame our weak willpower, completely failing to realize we are trying to fight our biology with a cardboard shield. Perhaps it's time to ask ourselves an uncomfortable question. Why do we keep punishing ourselves for what helped us survive? Next time you find yourself in front of an open fridge at 11 p.m., staring at a piece of pie in the cold blue light, don't rush to scold yourself for weakness. Look at this moment differently. You are not weak-willed at all. You are simply a Stone Age human trying to adapt to a world where, for the first time in history, there is too much food. And perhaps the first step to gaining control over your nightly habits is not another strict diet, but simple self-forgiveness.